Question 6th A part. Describe how the coefficient in linear regression are estimated using either the closed form equation or gradient descent. Linear regression coefficient estimation. Linear regression models a target variable y as a linear combination of input features. Y cap equals to W0 plus W1 x1 plus W2 x2 so on till Wn xn. The goal is to estimate the coefficient W0 W1 till Wn so that the prediction fit the data as well as possible. We do this by minimizing mean squared errors MSE. JW equals to 1 upon 2m summation of a yi cap minus yi whole square from I equal to 1 to m. There are two standard methods. First is closed form solution normal equation. In matrix form, X is total matrix with a column of ones for intercept. W is coefficient vector, Y is target vector. The optimal weights that minimize MSE are obtained directly using W equals to X transpose X whole inverse X transpose into Y. Explanation. Compute X transpose X, compute its inverse, then multiply it with X transpose Y. The result gives the best fit coefficient. Advantages are extract mathematical solution, no learning rate, no iteration needed. Limitations are computationally expensive when features are large, requires matrix inversion which is expensive, not suitable for very big dataset. Second, gradient descent. Gradient descent is an iterative optimization method that gradually adjusts coefficient to reduce error functions. Update rule. For each coefficient Wj minus alpha d of j upon d of wi, where alpha is learning rate, d of j, d of wj equals to 1 upon m summation of xi cap minus xi yi cap into xj I from I equal to 1 to m. Steps are initialize all coefficients, example zeros, compute prediction y cap, compute the gradient partial derivative of cost function, update each weight using the gradient descent rule, repeat until convergence when cost stops decreasing. Advantages. Works well with very large datasets. It avoids expensive matrix inversion. Can use mini batches SGD, mini batch GD. Limitations needs a learning rate, may converge slowly or get stuck if alpha is poorly selected. Features closed form normal equation and gradient are structured over here as a table. Question 6b. Explain logistic regression and use the logistic function to calculate the probability of a class for a given input. Example, logistic regression is a classification algorithm used when the output is binary. Yes, no, 0, 1, fraud, no fraud, BNS 80, not yet BNS 80, etc. It predicts probability that an input belong to the positive class. Probability of y equal to 1 given x equals to p cap. It does this by First, computing linear combination of features z equals to beta naught plus beta 1 x1 plus beta 2 x2 so on till beta n xn. Passing z through sigmoid logistic function to convert it into probability. Sigma z equals to 1 upon 1 plus e to the power minus z. Logistic sigmoid function. The sigmoid function converts real number into a value between 0 and 1. P cap equals to 1 upon 1 plus e to the power minus z, where P is predicted probability of class 1 and P cap is greater than equal to 0.5 and predict class 1. If P cap is smaller than 0.5, predict class 0. Suppose we built a logistic regression model to predict if a case fails under PNS80 dowry death. The model coefficients are feature intercept, symbol is beta naught, values 2 minus 2. Dowry demand 1 for yes and 0 for no, beta 1, 1.5. Marriage year, its symbol is beta 2, value is minus 0.3. Burn injury, 1 is yes, 0 is no, beta 3, 2.1. Input example FIR case, dowry demand value is 1, average marriage year is 2, born injury value is 1. Step 1, compute the linear score z equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. Plug in values and we'll get z equal to 1. Step 2, apply the logistic function P cap equals to sigma of 1.0, which is equals to 1 upon 1 plus E inverse. By calculating P cap, we get the value 0.731. Final prediction P of PNS80 given X equal to 0.731. Here is the concept meaning table. Logistic regression meaning model of binary classification. Linear score Z is weighted sum of inputs. Sigmoid function converts score into probability. Output probability of class equals to 1.